Periodic table consists of 18 groups and 7 periods. Groups are the vertical lines in the periodic table, while periods are the horizontal lines. So if I pick, for example, element O, O is in group 16, period 2. Another example, if I take, let's say, if I ask about gallium, gallium belongs to group 13, period 4. One more example, if I take the element sodium, sodium belongs to group 1, period 3. So always keep in mind that the vertical lines are the groups and the horizontal lines are the periods. Now there is a relationship between the group and the number of valence electron. So element belonging to group 1 has 1 valence electron. Any element belonging to group 2 has 2 valence electrons. Any element belonging to group 13 has 3 valence electrons. Any element belonging to group 14 has 4 valence. Group 15 has 5 valence electrons. Group 16 has 6 valence electrons. Group 17 has 7 valence electrons. And for group 18, except for helium, helium has 2 valence electrons, while the rest of the elements of this group, they have 8 valence electrons. So if you know your element and you have a question to identify how many valence electron, you directly relate the number of valence electron to the group number. So for example, you have a question, identify the valence electrons of chlorine. Chlorine belongs to group 17. It's right here. So it has 7 valence electrons, not 17, 7. Or for example, if I have a question about selenium, selenium belongs to group 16. Selenium is in group 16. So selenium has 6 valence electrons. Now, there is a direct relationship between the number of valence electrons and Lewis structure. In Lewis structure, we represent the valence electrons by dots. Valence electrons are represented by dots. And many students, they get confused with this. So for example, they read on oxygen, nitrogen, carbon, let's say boron, 9, and this is 10. So for example, they get a question to write Lewis structure of fluorine. So they go and they put 9 dots. Or Lewis structure of carbon, they go and put 6 dots, and that is wrong. You do not put the dots as the total number of electrons. The dots are simply the valence electrons. So if you notice here, in group 1, we have 1 valence electron. All the elements, regardless of how many electrons they have, each will take 1 dot next to its symbol. Elements belonging to group 2 will have 2 valence electrons. So when writing their Lewis structure, we place 2 dots. Elements belonging to group 13, they will have 3 valence electrons. So when you are writing the element with the symbol, you only place 3 dots, and so on. Now for helium, helium, as I mentioned, is the only one belonging to group 18, but it has 2 valence electrons. And in order to differentiate between helium having 2 valence electrons and the elements of group 2, we place the dots paired in helium, next to each other in helium. Now, one more thing you need to learn about the elements in the periodic table. Any element written in this side of the periodic table, including helium, will be called S block element. So these are the S block elements. So when writing their configuration, it will end with S. Anything here, if I write the electron configuration, I will stop at D. So these are the D block elements, or also what we call the transition metals. Now these are just metals over here, metals. Now, all the elements over here are the p block elements. So when we write their configuration, we stop at D. And the p block elements include metals, nonmetals, and metalloids. And there are those two lines below the periodic table are the F block elements. So their configuration ends with F. The last thing we write is F, and these are the inner transition metals. The inner transition metals. Now, one more thing. Here's a table showing in blue the metals, which is S block, excluding hydrogen, S block, all the D, all the F are metals, some part of the P, Now, the P block elements, majority are non-metals, which are the elements on this side. These are the non-metals. And you have the stairs, which is showing over here. These are the metalloids. So for example, let's say you have a question given to you. They're giving you the orbital diagram notation. To which block these elements belong to? You directly look at the end. This orbital diagram finished by P. So this belongs to P block. How many valence electrons we have? For determining the valence electrons, you can either count how many electrons we have and then go to the periodic table to identify which element is this and in which group, or you can simply look at the highest level reached. And the highest level reached here is 3. Note that these numbers show the level filled with electron. And the highest level filled with electrons here is 3s and 3p. So in 3s we have 2 electrons, and in 3p we have 2 electrons. So the total number of valence electrons is 4. And if I have 4 valence electrons, it means that these elements belong to group 14. Identify the period. The period will be the highest level reached again, which is, we finished in line 3. We finished in the horizontal line number 3. So this is period 3. Now, if we look at this element in the periodic table, it is 3p2. This means that this element is silicon. This is the first line. This is the second line. This is the third line, or I mean period 3. Now here's the S area, and here's the P area, P block. Now, since this element ended in 3p2, because this is 3p1, this is 3p2, 3p3, 3p4, 3p5, 3p6. So this configuration ended with 3p2 being green. This is a metalloid. Let's take another example. Suppose we have element Q with this given electron configuration. To which block this element belongs to? So the last letter written is S. So this is an S block element. Now, how many valence electrons? The highest energy level reached here is 4. Not 3, not 2, not 1. The highest number reached, the highest energy level reached is 4. And in this 4, we have only 1 electron. So it means we have 1 valence electron. And if we have 1 valence electron, then this element belongs to group 1. Now identify the period. Again, the period would be the highest level reached. So it is period 4. Now let's look at 4s1. So this is the S block, and this is period 1, period 2, period 3, period 4. So this is 4s1. This would be 4s2. So this element is over here, S1, and it's in the blue color. So this is a metal. And by the way, all the S block elements are metals. Finally, we have this noble gas notation of a certain unknown element R ending with letter D. So this element is a D block element, which is a transition metal. How many valence electrons? Always, to identify the valence electrons, we need to look at the highest level reached and not the last level written. The last level written is 3, but the highest level reached is 4. And in 4, we have 2 valence electrons. So this one has 2 valence electrons. Identify the period. Again, the highest level reached is 4. So this element belongs to period 4. Now, since this element ended with D, so it's a metal and specifically a transition metal.